Hi everyone, good morning, good afternoon, good evening, wherever you are. I'm your host, Dr. Haider Shah. On behalf of Kalwas, I would like to welcome all of you to this webinar. Thank you very much for joining us. Today we have another very interesting topic, and I'm really honored to welcome and introduce our distinguished guest speaker who is going to talk about data analysis using Gretl software. Indeed, data analysis is very crucial part in the thesis as well as in research paper. You need to learn it properly. Really very interesting topic, and I'm sure you are going to learn a lot in this session as we have an expert with us in today's this session. So you will get the best insight, right guidance, and suggestion about all these things. So stay tuned because an amazing stuff are coming ahead in this session. So before we start, I would like to thank all of us for arranging such enlightenment sessions, for their support and providing us such a wonderful platform. The aim of Kalwas is to give you the opportunity to connect and interact with world renowned speakers, academic leaders, teachers, authors, researchers, experts, professionals, and businessmen to learn from their experiences, recommendations, suggestions, and tips which will create an impact and will enable you to learn and develop yourself individually as well as to contribute to the world in a positive way. As our slogan is come, learn, and share knowledge. So today we have an amazing person as guest, a person having a wonderful experience in academia, international known personality. He's a great human being. I always see him while contributing to the world through different platforms, and he is always ready to share his knowledge. So let me introduce him formally. He holds a PhD degree from University Technology Malaysia (UTM) and is working as an assistant professor at Lyallpur Business School, Government College, University Faisalabad, Pakistan. He has more than 10 years of teaching and research experience in the field of accounting and finance. In addition to that, he has authored many research articles in ISI, Scopus, and HEC recognized journals. He is managing editor of Journal of Marketing and Information System. He is also reviewer of many reputable journals like Sustainability, the Foresight, Inter Sciences, Pakistan Journal of Multidisciplinary Research, and Reader Insight journals, etc. Moreover, he is an editorial board member of Journal of Economic Info and Journal of Management Info. He is also a founding member of Connecting Asia and the EPRA Research Network. Along with that, he is an expert in quantitative analysis and also professional trainer of Stata as well as the Gretl software. Last but not the least, he's a wonderful speaker, author, teacher, researcher, professional, and above everything, a great human being. So please help me in welcoming our guest, Dr. Hamad Raza. Welcome to Kalwas platform, and thank you very much for joining us. Dr. Hamad Raza, your mic is mute.
This is the Assalamu alaikum. Thank you, Dr. Haider, for inviting me for this session. And first of all, Assalamu alaikum to everyone, everywhere in the world. It's morning, afternoon, or night, different parts of the world. So I welcome all of you in this session. I will try my best to explain this Gretl software, which is one of the most important software and easy to learn software in terms of data analysis. You can write written paper using this software because the data analysis in this software is very easy and you can perform very well using this software. So before further delay, I want to share my slides and start with the session.
Yeah, it's really great to have you, Dr. Hamad Raza. Thank you very much. So Dr. Hamad Raza will be presenting and he would leave time for question answer session. You can ask question at the end of this session. You can write in comment section or you can email us. So let's get started. Over to you, Dr. Saab. Thank you.
Dr. Haider, can you see my slides?
Yes, it's visible. Carry on, please. Thank you.
Yeah. The topic of today's webinar is data analysis using Gretl software. My name is Dr. Hamad Raza. I'm assistant professor in Lyallpur Business School, GC University, Faisalabad. Dr. Haider has already told about my introduction, so I will skip this part and I will directly go to the learning outcomes of the webinar. So first of all, in this webinar, we will discuss the basic understanding of panel data and the types of panel data, the importance of panel data, to know about the models for panel data, understanding the Gretl interface, and checking diagnostic tests, how we perform in Gretl, what are the panel models that we use to estimate using Gretl software, and how we select the appropriate panel model using Gretl software. So this all you will be know once you attend this webinar. You will be able to perform all these functions. And last but not least, I will try to explain the results and interpret the results. What are the basic findings after performing the data analysis? Panel data. As you know that panel data is the set is one where there are repeated observation on the same unit across companies, across times. As there are different types of data, so before going to panel data, I want to discuss that the data can be divided into different types. Like we have cross-sectional data, like we have only one company of data. And we have panel data in which we observe the time, also the unit, that is company, over different number of years. So the panel data is one of the most important data that in recent time is used for data analysis. So for today's workshop, that's why this is the reason I have selected the panel data. So panel data is just a data set where there are repeated observations on the same unit across times. Means you have selected one firm and there are different number of years. So we will observe the performance of that firm over number of years across the time. The unit may be individual, firms, countries, or any set of entities that remain stable through time. Uh, for example, the data related to financial profitability, if we are taking the data of any non-financial firms in Malaysia, like we want to take data from 2018 to 2020, the financial data of the same firm were collected every year across 3 years. So this represents the panel data, how we collect the data, and what are the patterns for panel data collection. As I have explained, that data can be of different types. Number one, the data is one of the most popular data is time series data, in which the company remains the same, but its performance is changed per year. So we try to analyze the same firm over the number of years. Means we need to see the internal comparison of the firm over the years. In the cross-sectional data, here, the company will change, but the time period will remain fixed. But the panel data is the combination or hybrid mode of these two data. So in which we also change the number of years as well as we change the number of firms. Like, for example, we take some part from the time series data that in firm A, we check over number of years, and then we change different firms also and check for the same number of years. For like I have discussed, I have taken 3 years, so I will check firm A for 3 years, then firm B for 3 years, and then firm C for 3 years. So this is how we will collect the data for the panel data firms. Type of data. There are two types of data. One data is balanced panel data, and the other one is unbalanced panel data. Balanced panel data is the data where all the observation or information is complete. Means you get the data for each number of years. Like in this table, table 1, you can see that the firm A data we can find for 2018, 2019, 2020, and same for B and C. We find data for all 3 years. But when you go to unbalanced panel data, table 2, here we can find the information for firm A for only 2 years. Means 2018 is missing. We cannot find the data for 2018, and same for the firm C. We cannot find the information for 2019 or 20. This can be the reason, like for firm A, it may be the reason that in 2018 this firm was not operationalized, or it was not in the market. So from 2019, the firm came into the market and the data was available. And same for the firm C, it may be the reason that in 2018, this firm closed its operation and is not available in the market. So the last information for the data for which we have collected the data from 2018 to 2020. So we are able to find only this number of years of data. So this kind of data set is called as unbalanced panel data set. Importance of panel data set. Panel data can model both the common and individual behaviors of group. This is one of the most important panel data set that contains more information, more visibility, and more efficiency than pure time series data and cross-sectional data. That's why in recent times, panel data has been given more importance, as it has more visibility and more efficiency than time series and cross-sectional data. Panel data can detect and measure statistical effects that pure time series or cross-sectional data cannot. Last, panel data can minimize estimation biasness that may arise from aggregating groups into a single time series data. There are different models for panel data. The first model that we use in data analysis for panel data is pooled OLS model. Pooled OLS model believes that there are no unique characteristics among cross-sections like firm or country. There are no uniqueness. So this is the basic, what you call the hypothesis for running the pooled OLS model. And number 2, no universal effect across times. Means the effect of times does not affect the cross-sections like firms. Number second model, the panel model, is fixed effect model. Fixed effect model believes that there are unique features of individual cross-sections that do not change during time. These unique features are not correlated with individual independent variables of cross-sections. Means fixed effect model means that the firms remain fixed over a number of period of time. There is no changes of firm over the time. So this is the model when we run the fixed effect model. And the third one is random effect model. Believes that there are some systematic random effect of individual cross-sections. Means the firm's cross-sections may be changed over a period of time. There are unique time constant features of individuals that are not correlated with the individual independent variables. Means the cross-sections, like in our I explained previously that cross-sections are the firm, like here, cross-sections are the firm or the country. So in random effect, there is some systematic random effect, systematic changes over time for that firms or country. So there we will select the random effect model. Basically, the panel data models are of two types. Number one is fixed effect model, and number second is random effect model. These two models are known as panel data models. So before running these two models, we need to run pooled OLS model, which is the basis for these two models. On the basis, once we run the pooled OLS model, then we are able to decide which model is more preferable for our data set. And it is decided by using Hausman test. Hausman test tell us how our panel data will be selected. Before running the pooled OLS model and these regression models, we need to have a diagnostic test. So the first test for the data is normality test. Normality test, there are different types of normality tests, but for today's workshop, we will be running normality test using Jorbara test. And the second one is multi-colinearity test. Multi-colinearity test basically tests the variables correlation, whether the variables, the independent variables we have selected are correlated with each other. If the value of VIF is greater than 10, it means that the multicollinearity exists between the data. So for today's workshop, we need to test the multicollinearity using VIF test. The third one is the heteroscedasticity in the data. Heteroscedasticity means the data is scattered, is not on average, is scattered. You have down, you have low values as well as high values, and also the middle values. So the data is scattered. So this heteroscedasticity in the data is measured by using White test, which was presented by White in 1980. And the fourth diagnostic test for data analysis is, and for running regression analysis, is linearity. Means the variables which you have selected should have the linearity. Means if you have selected the variables in ratios, so all data should be in ratios form. Selection of appropriate panel model. As I have discussed that there are two types of panel model. Number one is random effect model, and number two is fixed effect model. So for better selection of that model, we use Hausman specification test that decide us or tell us which model is better for our panel data analysis. So if our p-value for this Hausman test is less than 5%, it will reject the null hypothesis, which says that random effect model is appropriate model. Whereas if the value is less than 5%, we will select our alternative hypothesis, which is fixed effect model is appropriate. And if the p-value is greater than 5%, then we will our null hypothesis will be accepted, and we will use the random effect model. Key features of Gretl software. The first key feature of this Gretl software, which I have selected for today's workshop, is this software is free of cost and easily available online, and it is a open source software, which is one of the most advantage for students as well, for business as well, that this software is free of cost. You don't need to spend money to analyze, to write the papers, to analyze your data. The second most important feature is that this software is intuitive interface. Means you have graphical user interface, which is very easy to use instead of other interfaces which have command prompts, and you have to learn and write the commands in the interface. This one is graphical user friendly software. Wide variety of estimators. You can test both panel data as well as time series or cross-sectional methods in this software. And this software outputs can give you in the form of latex files or tabular or equation files or graphical form. You can get the output. So this one is very good for your data analysis, for your thesis, for your papers. And this software can be downloaded from this source. So without waiting, let's begin with our hands-on session for our data analysis. Before going to Gretl software, I will try to explain the worksheet that we need to prepare for our data analysis. The sheet that we open or run in the Gretl software is based on Excel sheet. So you need to collect your data on the Excel sheet, and here is the format for the panel data. In the first row, you need to collect the firms, the name of the firms you have to write. Then in the second column, you have to write the number of years for the number of years you are taking data. Like I have taken this data from 1993 to 2010. So I have taken data for around 17 years. Then variables you have to take. In my example, this first variable, share price, is the variable which is dependent variable, and I will be determining the determinants of share price using EPS variable, earning per share, firm size, and dividend per payout ratio. So these three variables will be independent variables in today's workshop, which is earning per share, firm size, and dividend payout ratio. And the share price is the dependent variable. I have taken share price in the annual share price rate, and then I have taken the lot of that share price. So it is now converted into lot form of share price, which ranges from 0 to 1. So these are the lots of different share prices, and here all the EPS, firm size, and also dividend payout ratio. These all dividend payout ratio and EPS are taken into the ratio form, and firm size we have taken the lot of uh, total assets. So from taking a lot of total assets, we have uh, collected the data for firm size. So this is the Excel sheet, how you prepare the number of observations, and these companies are changing after every 17 years. The next company name is coming, you can see here. So the total number of observations which I am using for this workshop is around 1,000, I think. So if I'm not wrong. It's 1117 observations we have collected all together. And here I want to show you that these empty boxes are there also in share price, and also two empty boxes in these two variables, earning per share and firm size, and these empty boxes in dividend payout ratio. These empty boxes shows us that this company may not be performing their operations, or the data is not available for these number of years. So this represents that the example which I am taking data is unbalanced panel data. So this there are missing number of observations for in this data. Now we move towards the Gretl software. This is the symbol of the Gretl software, and we will click on the Gretl software to open the software. This is the graphical user interface of Gretl software. So you need to upload the file. You need to open the file, open data, user file, then click on the location where the data is placed. My data file is on desktop, and here is the Gretl workshop folder. And you need to select Excel file, as my data is in Excel file. So click open. It's asking to import the data from the Excel file. So I will try to open the data. I will click OK. Then it is showing that one valid sheet is found. There are 6 variables and 116 observations. So the first row, which in the Excel sheet we see that there was 1117 observations. So the first row was of variables which he has already found out that there are 6 variables and 1116 observations. So the software automatically assign from the first row as variable 1 and the following variables numbers. So we just click close. This is the automatic, and then this Gretl software is asking that the imported data has interpreted as date, update undate data dated cross sections. Do you want to give the data a time series or panel interpretation? If you select no, then this software will treat your data as only cross-sectional data. But if you want to give your data a time series or panel interpretation, so you click on yes. So for today's workshop is panel data, so we click on yes. Then there are 3 options. First one is cross sections. The second one is time series, and the third one is panel. So we'll select the panel data and click on the forward. Then we use, you can select any option you want, but most appropriate for us is to use index variables, in which we can see the name of our variable. Then we click forward. The units of the group will be your firm. The firms will be unit, and the time variable will be years. So they will automatically select your firms and time years, that variable, and you click on forward. Then they say that panel data stat time series 64 cross-sectional units observed over 18 periods, mean 18 periods starting from 1993 to 2010. So all 1993 and 2010 includes 18 years of period of data. And I have taken 64 cross-section units, means there are 64 forms of data in this sample sheet. So we click on apply. And here we go. We can see that our forms has been assigned the code, and the first form will be having the codes like 45 or 1 or 2 or 3 and so on, 64 forms for each number of years. So first of all, for our data analysis, our sheet is uploaded, and we can see the variables have been uploaded and assigned the numbers IDs. The first number represents the forms, the second number represents the years, and third represents our dependent variable, that is share price, and the fourth represents our earning per share, and fifth represents the firm size, and sixth represents the dividend payout ratios. So 4, 5th, and 6th variable IDs are basically the independent variables for today's workshop, and the third ID is the dependent variable, that is share price. So first of all, we will start our data analysis by seeing the descriptive statistics. For descriptive statistics, you need to click on View, this View tab, and simply click on View, and then you need to see the summary statistics of your variables. So click on Summary Statistics. These are the variables which you uploaded, and here you want to see which variables summary statistics. For example, we want to see the summary statistics of all our dependent and independent variables. So we will select our variables, and we will click on this add, and then we click on OK. It is asking for, you want to show the main statistics or you want to show the full statistics. So in the first example, I will go with the show main statistics. These are the main statistics. Here we can find in the main statistics, that is mean, the mean of each variable, and also the median of each variable, the standard deviation of variables, and the minimum and maximum uh, value of each variable. As I have discussed that this share price minimum value is 0. Share price cannot be 0, but once we are taking the lot of share price, so the value of a lot can be 0. For example, if a firm is running in the market and the share price of that firm is 1 rupee, so when you take the lot of 1 rupee, it will comes 0. So that's why this amount is 0, and the maximum amount, maybe this amount will be 500 or 1000, and the lot of that amount will be 7.601. And similarly, for dividend payout ratio, the minimum amount is 0 and the maximum amount is 36. 0 represents that this company has not paid that dividend in some particular year. So in that year, the minimum amount will be 0 and the maximum amount will be 36%. And similarly, for earning per share, the some amounts are negative and some amounts are positive. Means minimum amount is negative and maximum amount is positive. This can be the case that in Pakistani firms, because this data is collected from Pakistani firms. So in this data, some companies have more earning, shareholders earning than net profit. So the ratio becomes negative over here. If we again run the summary statistics and we see what is the difference between the main features and the main statistics and the full statistics. So we click OK, then show full statistics. As you can see that here number of variables are increased. The main statistics include only mean, medium, minimum, maximum, and standard deviation. But when you talk about full statistics, so you can know the skewness or kurtosis and percentage, 95% value or 5% value, and IQ range and missing observation, how many values in any individual variable is missing. Like in share price for this 18 years data for 64 firms, there are total 167 observations which are missing. Means you will minus 1116 observation minus 167, the remaining observations you have collected for this share price data, and similarly for other variables. The next step in the data analysis for our write-up is we want to see that correlation of variables, dependent and independent variables. So we'll select on view, and beside the summary statistics, there is correlation matrix written. So we'll click on correlation matrix. Here again, we will select the variables dependent as well as independent variables, and we'll click on add and press OK. So this outcome will come in the form of table. Like this one is share price 1-to-1. EPS has 27% correlation with share price, and size has 36% correlation with share price, and dividend has 49% correlation with share price. From this table, if the value is less than 0.70%, 0.70 means 70%. If the value is less than 0.70, the writers say that there does not exist any colinearity or issue in this data. So we can analyze data for our further step. Then we once this we have checked the basic summary statistics and correlation metrics of this data. Then we will go to the model, and we will start with our pooled OLS model, so that first we will run pooled OLS model, and then we'll check the diagnostic test for our data analysis first. So we'll select on ordinary least square, which is pooled OLS model name in this software, and then we will this interface will come, pop-up window will come. So we'll select the dependent variable. In our case, share price is the dependent variable. We'll select, and other variables are independent variables. So we will redress these variables against our dependent variable. So we'll put over here, and we set as share price as our default dependent variables. So we'll select on our OK. So this pop-up window will comes up with the result. We will discuss this result later on. First, we will go to the diagnostic test, whether we can go with this data set or not. So we'll click on the test, and here you can see that there are different type of tests, but we are talking about 4 tests. The first test is normality test. So normality test is started by this normality of can be tested by normality of residual. You click on normality of residual. It's calculated. Yeah. So this software gives you both graphical view as well as statistical value of this normality data. As you can see that the most of the range of the data should be in this tough form, but here are some values which are outlier in this data, and also these values are a bit high in this scenario center, and so the data is mixed data, and there are some low values as well as high values. So both negative values as well as positive values exist both ends. So this data, I think, if we can see the p value shows that the data is value is greater than 0.05, which shows that the null hypothesis is rejected. Means there is the null hypothesis states that if the p-value is less than 0, then if the p-value is less than 0.5, it means that it is significant and the normality exists in the data. But if the value is greater than 0.5, it means that the normality does not exist in that data. But for the panel data, here the p value states that the normality of the data is not there. But for the panel data, this is the beauty of panel data, that if the diagnostic test of this panel data is not normal, or states that it is not normal, but for panel data you have some relaxation, that as you are collecting the data of different forms over a different number of years, so every form is different from the other form, so the data of that forms will also be different, and there will be missing observation as well as, so the data will not be same. So the issue of normality will be there. So the this normality issue is not much considered in this panel data. So you can run the you can run the data analysis on this type of data if there is some issues in normality. The next test we are doing to for the diagnostic is we will check the hydrostaticity, and for hydrostaticity we will check the white test. So we'll select on hydrostaticity in the test, and we will select on white test. So white test shows us that the p-value is 0.00, which means that if the value of p-value is less than 5%, it will reject the null hypothesis. Null hypothesis states that there is no hydrostaticity issue. And if the p-value is significant, then it shows that the hydrostaticity issue exists in this panel data. So to solve this, to resolve this hydrostaticity issue, White 1980 have written in his paper, which was published in 1980, that if you are taking the panel data and the number of years or number of observations are more than 100 observations, there is a chance that the heterostoticity may exist in the data. And to resolve this heterostoticity, you need to run your results reboost. So reboost will remove or solve the problem of heterostoticity in your data. This I will tell you how we will run our results reboostly later on, once we will analyze the models. So the second diagnostic test is hydrostaticity. The third one is we will check the colinearity of our variables. So we'll click on analysis, and here we will find the colinearity. Click on it, and here is the VIF factor, which is the value greater than 10 may indicate colinearity problem. But in our independent variables, all values are less than 10. So there is no colinearity issue in this data. But if, for example, you have taken different variables and the value of that variable is of any of your variable is greater than 10, so in order to solve that problem, you need to either readjust the data, or you need to drop that variable so that your model have two variables which are very closely related to each other. So you need to drop one of the variable in order to resolve your VI factor lower than 10. So if all the variables value is less than 10, so it indicates that the tolinearity problem does not exist in your data, which is shown in this sample sheet. So as we have already discussed all the type of diagnostic tests, so our data is now in a shape to we can easily run our models. So we can proceed with our regression analysis. So for the regression analysis, we will start with our pooled OLS model, which I have discussed that before running the panel data models, we need to run the pooled OLS model, which is the primary model for selecting the panel data. So we'll select on model, then we will click on least ordinary least square. OLS means ordinary least square model. Then here share price is our dependent variable, and all independent variables are put into the regressor automatically. So as I have discussed that in the diagnostic test, there is just a hydrostaticity in our data. So we need to, according to White 1980, we need to reboost our standard errors so that hydrostaticity of data can be resolved. So we'll click on this, simply click on this reboot standard error, and then we will click OK. And you can see that our result of pooled OLS model is here. We have earning per share is significant at 5%, and size and dividend payout ratio is significant at 1%. And our overall, for panel data, we see the p-value of the p-value is also significant, that is less than 1%. And also our f-test is value is important for our panel data, that is 24.150. This shows that our model is all the three determinants, all the three variables are the best determinants for our share price value. But if we compare, if we use the data and we does not reboost our results or reboost our standard errors, then the findings will be different. And there can be misleading in the data. So if we can compare these two outputs, this model 3 is run without reboosting our standard errors. This shows that hydrostaticity exists in this data. And this model 2, we have reboosted the standard errors, so hydrostaticity is solved. So we can see that here the significance level of variables have been changed, and also the significance level is changed, and certainly the f value of is also, and p value is also changed. So for heterostochasticity, we need to run our model using reboost standard errors, which will give us more appropriate and accurate results or findings. In order to run panel models, we need to decide whether fixed effect model is better or random effect model is better for our software, for our data. So in this way, you will go to this pooled OLS output, and you will click on test, and there is one, written in the bottom, that is panel diagnostic. Panel diagnostic, which I have explained in slide, that we will take Horseman test. If the value of Horseman test is less than 5%, then fixed effect will be selected. If the value is greater than 5%, then random effect will be selected. So we click on panel diagnostic test. So here they will automatically first run the fixed effect estimators, in which they can show, which shows that size and dividend per share are the two variables that are significant, and then they show us the random effect model, which also state that firm size and dividend ratios are significant, but their sufficient values will be different. And so here at the last is the Horseman test, on the basis of which we will select our appropriate panel model. As you can see that the p-value, this p-value is significant, means 9.64 and in power minus 12, means 0.00000096 is the value for this test. So which states that the null hypothesis is rejected. Null hypothesis states that random effect, if the null hypothesis is accepted, then the random effect model is consistent in favor of fixed effect model. And if the p-value is significant, then we will reject the null hypothesis, and the alternative hypothesis that fixed effect model is consistent and better will be accepted. In our this data, we will, on the basis of Horseman test, we will select the fixed effect model as it is most appropriate, as the p-value is less than 5% significant. So to run the panel model, we'll click on the model, and we will go to panel. There are fixed or random effect models. You click on fixed or random effect models. Then same as I have already ticked the set as default. So they have already taken the dependent and independent variables automatically. And then you need to run the reboost standard errors, as this data contains the heterostochasticity. In order to solve the heterostochasticity, we click on reboot standard errors. Then we need to select our model. Either you want to run random effect model or fixed effect model. As I explained that Horseman test in our case is the p-value is significant, which states that alternative hypothesis, means fixed effect model, is more appropriate for our data. So we'll click on a fixed effect model, and then we will click on OK. This output will come out in the form of model 4, which states that this model is fixed effect model. And these are the number of observations. These are the cross-sectional units. And the Output shows that only two variables out of three are have the significant relationship with the share price. Means firm size and dividend payout ratio has a significant relationship with share price, and both have the positive directions. And the F and the p value for this model is also less than 5%, which states that our model is significant. This is the p value, which is less than 5%. And this is the F statistic value, that is 20.38. So this is how you will run the models in the Gretl software, and you can analyze your data using Gretl software. That is all from my side in explaining the data analysis using Gretl software. If there is any question, I open the session for the question.
Yes, Dr. Hamad Raza, it was so wonderful and so nicely you presented. And I love the way you started from the theoretical perspective. You talked about the software, how it is beneficial, and even from Excel sheet, how to make the entries, what are the different headings. And then you talked about the normality of the data, the multicolinearity, and all these things. Again, on the hands-on practice you mentioned, and you connect the different dots of theoretical to the practical session, that whatever you have said you have covered in your hands-on practice session. And I love to see that even the p value, you showed the p value, that how it is interpreted and everything, what was so nice. Dr. Hamad, you would agree with me that this is what you have been doing practically and on campuses on different places, but now even on such a virtual platform you have done a fantastic job. You have done the same way. Even I did not feel that I'm not sitting in the somewhere hall and you are teaching us, because the way you were showing and the way you were explaining the things was so superb. I would say fantastic job, congratulations, because the message you wanted to convey to the across the globe was already is already conveyed, and in a wonderful manner. Thank you very much for such a wonderful explanation, presentation, and powerful content. Yes, of course, we have certain questions for you. If you allow me, should we start with the first question, please?
Please, Dr.
Yeah.
Shah.
Okay. The first question, Dr. Hamad, they want to ask that what is the minimum number of observations required to estimate panel data in Gretl? Yes, please.
Uh, uh, as far as the minimum number of observations for panel data in Gretl, Gretl can handle the minimum observations less than 100 also. But if we can say about standard number of observations for panel data, so for to run to have the better results from your data, at least your number of observations should be 100. So if the data is having less than 100 observations, software will perform its analysis, but you will not get the accurate results of your data. So in order to get the accurate results, the observation should be at least greater than 100, according to White 19 and 18.
Yeah, very nicely said. Thank you very much for such a elaborative answer for that. Dr. Ahmad, we have another very interesting question, and that's the student wants to ask that Dr. Ahmad, please guide me. I run a model with the panel data using Gretl. So please guide me about the interpretation. I need a detailed note and your recommendation to what to consider. Should I consider the sign, significance, and magnitude of the coefficients of these variable, the overall model fitness, and what else do you recommend to me? Yes, please.
Yeah, Dr. Haider, for this uh, panel data interpretation, first of all, we will see the overall fitness of the model. As I have
Mhm.
explained in my practical hands-on workshop, first you will need to see the overall fitness, and you can see from the p-value. If the p-value is significant, then it means that your model is overall fit. And then the second thing, for the panel model, you need to see the value of f statistics instead of r square. For cross-sectional or time series data, r square is more important, but for the panel data, you need to see the abs-statistic value of the model. If that value is on the lower side, it means that the overall fitness of that model is more appropriate. There is no particular definition of abs-statistic value, but it shows that if it is more towards downside, more towards zero, then it is considered that the model is more appropriate. Like in my example, when I tested the data using pooled OLS model, it shows the abs-statistic value that is 24, but and the p-value was less than 5%. But when I run the data with the panel data model, that is fit effect model, so the p-value was also significant, but the f-statistic value was 20. So which
Mhm.
shows that the panel model data is analyzing your data more accurately instead of pooled OLS model. So that's
Mhm.
why this is the beauty of the panel data. Yeah.
Very nicely said. Thank you very much again for a wonderful explanation. Dr. Ahmad, we have another very interesting topic, and they want your opinion since you are the expert in that. The question is, Dr. Ahmad, you are the expert in Stata as well as in Gretl. Please enlighten us what is the significant difference between the Gretl and Stata, and which one you think is more beneficial in terms of that both have its own pros and cons, but what do you recommend for a panel data analysis? Yes, please.
Yeah, Dr. Haider, as you already said in your question, that every software has both its pros and cons.
Mhm.
So we cannot say that Gretl is better or Stata is better. Every software has different attributes and different advantages and disadvantages. But the major advantage of this status of this Gretl software is that this Gretl software has a graphical user interface and easy to learn. But in the Stata software, you need to learn the commands. If you miss any command or any element of that command, your Stata will not give you the results. And that one is command prompt based. This one is graphical user interface. So you don't need to remember the commands by in your mind. So you can just run your data using graphical user interface. This is one of the basic difference between Stata and Gretl. Number second, if we go to the software, both software give us the, if you run the both data on both software, the results will be same. Means the output of fixed effect on the Gretl as well as from the Stata will be same. There will be no difference of data. So we cannot say that the Stata give us more accurate results than Gretl, because data is same. So the uh, programming language they have used differently, but they will calculate the data in the same form and the results will be same.
Yeah, very nicely said. And thank you very much for again mentioning clearly that yes, every software has its own pros and cons, and what are the beauty of this Gretl software you have explained in a very wonderful way. One last question, Dr. Hamad, please enlighten us about what are the limitations of Gretl software. Since you are the expert, you know very well what are the limitations of this Gretl software. Yes, please.
The I will discuss one of the limitations of this Gretl software. As I said in the start, that this software is the most easy and appropriate software to analyze your data. But and you can write your weekend paper using this data. As in 1 hour, I have done the analysis of my data. If I have collected the data already, so in 1 hour I can solve my analysis problem, and then we can just start up the write-up, and in 2 or 3 days we can complete our paper, because data analysis is the major part of our data. So one of the limitation of this Gretl software is that this Gretl software is basically developed on the basis of autonometrics. So only more appropriate results will be given for financial autonometrics data, rather than if you are testing your data related to management, in which we have collected the data from observations. So observational data, it's better to test your data, this kind of data on AMOS or Smart PLS, because this programming of this Gretl software is mostly towards data of financial autonometrics. I'm not saying that you cannot run this management data on Gretl software. Gretl does not know the background of the data, whether it is management, it is financial. It will analyze the results, but the more appropriate results will be given for financial autonometrics data rather than other type of data.
Yes, very nicely said, Dr. Hamad. Thank you very much for such an elaborative answer. And I would say the way you explained, the way you have shown through the practical session was so wonderful. Even I learned so new things from you. And as there is a popular saying that if you learn a single word from someone, that becomes your teacher. So you are my friend and brother, but now you are my teacher as well. Thank you very much for such a wonderful and enlightening sessions. That is so wonderful. Dr. Hamad, at the end, we ask our guest regarding what is your message to the world as a teacher, researcher, trainer, speaker, learner, and educator. Yes, please. What is your message to the world?
The message to the world is, as you know, that every day there is some new thing happening in the world. We have new informations, so don't stop learning. Always keep learning and update yourself according to the passage of time. Learn new softwares, learn new knowledge. Share your knowledge with your society as well, as it is one of the benefit of your learning. If you learn, you need to share with your society, and you need to provide the benefit to your society. This is my message. So first, as your call was motive is to learn and to share the knowledge. So this is what I want to say to the world. Please start, don't stop learning, and always learn new things and share with the society.
Yeah, thank you very much, Dr. Hamad. What a wonderful message you have given to the world that yes, learn, be a student in every aspect of your life, and then share your knowledge. That's the wonderful thing. I think that's the service back to the society. People like you who has gathered this knowledge with a very difficult way, in a very difficult way, with a lot of struggle, and now you are sharing with the world, and that's the beauty, because you are always available for them for their guidance. And I would say that this is real contribution to the field and to the world as well. Very nicely said. Thank you very much once again, the Dr. Hamad Raza. You made it very easy for us to understand. So I would say that yes, data analysis using Gretl software is very critical, and you must learn it in a very nice way, as the Dr. Hamad Raza has already elaborated to you. So definitely do follow the distinguished guest speaker through his research work, and you can email him for future learning and guidance. He's very generous and always ready to help the people. Moreover, wonderful explanation, powerful content, which Dr. Hamad Raza has already elaborated, will help you to learn and develop your understanding regarding the Gretl software. So take advantage of all the information, important tips and suggestions shared by an expert. So that is all we have time for today. Thank you once again, Dr. Hamad Raza. And also I would like to thank our audience who joined us. If you have any additional question about the information shared today, please email to us or connect to the speaker directly through his email or social media account. Thank you all for your support and liking our sessions. Stay tuned as many sessions are on the way. Please do not miss any session. Until next session, take care of yourself. Bye-bye.